Thank you for coming here to this session on a topic called Partner-Ready Software, with a subtitle of How to Build Software for Others to Maintain. Actually, this is only one aspect of it. It is Partner-Ready Software is for a much broader scope, and one of the things that we're going to do today is try to inform you about what this is all about. It's about having a flashy logo, of course. And this is our agenda for today. As I said in the introduction, we're going to talk about how we came about to do this thing at all. What was our offset? What was our scope? What does partner-ready software mean? And as you can see, this is not only Eric Wouters and myself who were announced as speakers, but also Mark Brummel, who is a generic part of this partner-ready software team. So we're going to start with where we started when we got together, and that was in Prague at EMEA Directions, and where it got us so far. And then we get to the session focus, which is production, this being a technical developer event. Of course, this is our session focus here, but it's actually not limited to production, what we do. Then we get some key takeaways, and one of the main key takeaways will be to get reaction from you, to find out what you think about this, how you can relate to it, what you make of all of this. So, how do we get into this? We got together and we're thinking, we've been in the NAV channel for quite some time, and we're thinking about, are we as successful as NAV partners and as implementers of NAV solutions and as vendors of NAV solutions, are we as successful as we could be or ought to be? And we have some very candid statements that we made. And the first is that ISV solutions, so NAV-based products, are successful domestically when they are implemented by the ISV itself, that is acting basically as its own VAR. But if it's taken out from the people who developed and originally implemented it and doing successful projects with it, then it becomes increasingly difficult to be successful. Now, of course, that is none of your problems. All of your products work where whoever implements them, I'm sure about that, but there are some exceptions. So, to be even more candid, we could say the current ISV VAR model is not as successful as it ought to be. And the IP that we produce with our NAV-based products is not interesting enough for shareholders to be selling as a product itself. Or to put it in other words, the products that we produce are great business functionality, but they are not products. So the second train of thoughts that we had in getting all of this together is what's around the corner, what's up, what's being talked about. And we find that the ERP world is changing dramatically right now. NAV opens up to the complete .NET community with NAV Interop and all of the integration scenarios. There is cloud-based computing, whatever that means, and whatever that means for NAV and for us.
But at least we are all in the cloud.
We're all in, yeah. We don't know exactly what we're in, but we're all in. And there is something like app-like functionality that is being talked about everywhere, of course at Apple, but also at Microsoft right now and other vendors. There is volume deals. Paul White is one of his main topics, how to enable NAV partners to do volume deals. What is that all about? How can we do that with our products? And Microsoft, as recently, there was a statement of Microsoft Germany this week only, Microsoft appears to be focusing more on the end customer. What does that mean for us, for our products? So the question that remains is NAV ready for this brave new world, to quote Aldous Huxley? We think actually, and that is maybe the most candid statement so far, and I hope that nobody from Denmark is here. That
I don't see them.
Okay, that's
We're
good.
safe.
That Navision is becoming NAV's legacy system, meaning that the old code, the old architecture, everything that we've built on is slowly becoming somewhat obsolete if we want to go forward. And that's, I think, a problem for all of us that we have to cope with, and that we have to, it's a challenge that we have to meet. So who did we think? What's that?
Oh my God! How did it come in?
Oh my God.
Someone must have made a big mistake.
I don't know. This is actually who we are. But let's go further. We're definitely not different than all of you. We are also working with the product. We also made probably more mistakes than anyone in this room. But we try to learn from it as you, and we try to how do you say, get others to work a little bit different like we are used to. Also, we support quite some developers, and we are also quite active in the community, so we see what people are doing with the product and how people think about the product, and that makes us a little bit dinosaurs, but trying to adapt also the dinosaurs that are out there.
We're trying to become a mammoth.
Yeah.
So that's who we are, and why we think we can be doing what we're doing. Now let's get a bit more closer to what does PRA partner software mean. So PRS is partner ready software. It is not a company. It is not a CD. It's not something that you can buy. It's not something that you just throw into your code and your solution becomes much better. No, it's what it is an initiative, actually. It is, let's say it's an attitude.
Mindset.
An approach.
Yes.
It's a series of guidelines, maybe, that we can develop, the three of us, all of you, we together with Microsoft. Maybe it's a forum. And what it is at best is a concept right now. And what we would like to do is look into that concept, and alongside that concept, we'll see a lot of very concrete examples what that means if you come down to architecture and coding. So, what is the scope? What is it all about? It is sales and marketing. It's architecture. It's development. It's project implementation. It's training. It's actually about everything that needs to come together for NAV-based products or projects to be successful. It's about taking a step back. Let's take a step back and look at the big picture. It's about realizing that the way we do NAV today is not enough to meet the challenges and the opportunities, and that's the most important thing, of tomorrow. It's about us working more closely together. It's about you getting involved and developing an understanding and for that. And it's about asking the right questions of how to leverage whatever cloud means, whatever app means, whatever volume deals means for us, and whatever we can do about it to make it more successful. More important, what is PRS not about? This is not a tips and tricks session, although I said we'll get to some good examples. The tips and tricks will be in Mark's session later on.
At the end of the day.
After lunch.
After everyone has left.
And it's not about claiming to have all the answers. It's more about maybe having the right questions. It's not a ready-made set of tools, as I said, and above all, it's not a dogma. Don't take anything that we think we say to be dogmatic, to be the only solution. That's completely beside the point. The point is to find the right way with everything that you do and that NAV does.
Yeah, you can compare it with Wiki and MSDN, that if you're on MSDN, it's true, and if you're on Wiki, you can change the text. So
Absolutely.
We are a Wiki, you can change the text.
I always thought people were wacko, but wikis are fine.
Wikis is fine. So the goals, in a very abstract way, are we want to make NAV projects more profitable. We want to turn NAV verticals into volume deal-enabled software. Wow, big sentence. Could come from Microsoft itself. We want to establish a professional industrial production process because the way we see it, many products based on NAV have started as projects and have packed together lots of functionality that applies to an industry, that applies to a vertical industry, but they have not really been software, something that is well built from an architectural point of view and from a coding point of view. That has not been the focus to start with. And that's why this is about making software instead of just solutions, because just solutions is great, but it will only get us so far. It will not get us into what is ahead now, I believe. So to break these abstract stuff down a bit into operationalizable statements,
quite high level.
we need Waldo.
I always don't know what he means, so I always ask him, can you please break it a little bit down, because I don't get you. And
he's in the cloud.
He's in the cloud, and I don't get the cloud. So it generally comes down to bring some fresh ideas and look at coding in a different way, look at your architecture in a different way, and maybe, it can help you in better coding, better architecture. It's about, creating more app-like stuff. Now, probably a question, what do you mean with app-like stuff?
Yes, Eric, what do you mean with app-like?
Yeah, you had asked that, so anyway. What I mean with app-like stuff is actually you have a mountain that's your software, or that's your solution, and you break that mountain down in all stones, and that stone is actually acting independently. When you have all the stones, you can actually create a solution or software with all the independent stones. And we try to break down that mountain and give you an opportunity to create stones, to create software with independently.
So what you have today, or what we have today, what many people have today, is a huge quarry, a huge mountain of functionality. You break that down into stones so that you can build something like a cathedral or something that sells better.
Okay, a cathedral will sell very
better. So
they are extremely popular.
Okay. So we want to. Another aspect of that is showing ways of establishing coherence and consistency in the complete process from business case to coding. We'll come back to that a little bit later. And also, what needs to be done is to establish communication with NAV core development at Microsoft. And we cannot, it's not possible to do this on a one-to-one business. On a one-to-one basis, we need kind of a forum, a channel to do so, to talk about future developments. So what does that mean? Bringing together consistency, coherency between business case all the way down to coding. I mean, I don't know if you have ever witnessed something like the architecture of your product does not really meet 100% the business case. Sometimes it happens, maybe. Then the way it is sold and marketed does not meet 100% the architecture of your software.
There is something in the marketing brochure which you say, well, this is not in my code.
And the way it is implemented, the way you have to set it up, is not really very nicely traceable in the code either. It's hard to actually find all of these separate code bits and pieces that you need to implement certain functionalities. Our approach would be to bring all of this into a coherent thing, to have a business case which states the requirements of the industry, to have sales and marketing that actually markets what the product offers and what the industry needs, to have an implementation process that shows how each requirement is actually handled by the product, and to have an architecture and coding of the product that is an easy to follow realization of that implementation process. There needs to be testing. We just had the testing session here with Buzz, very nice. There needs to be documentation, training, and certification. And above all, there needs to be extendability. So there should be well-defined extension points within the software architecture that allow your partners to hook in there and build upon that. And all that should be very coherent and consistent, and not done by several departments who maybe do not very often talk to each other. If we can show that in a picture, you have the business case, you have marketing, implementation, architecture, and training, and it all kind of works, but it should work maybe more like this.
I actually don't have to see your software as being an end solution for your end customer only. Of course, that's quite important. The customer has to work with your solution, but also your partners have to maintain, upgrade. We have to all there expand the solution as well. So the architecture is kind of like the same importance of the actual functionality that is going to be in there. So you have to think about that as well. All the things that sells a product.
There's always that last mile that you need to cover in any project and make it easy for your partner to do that. Your partner is a customer as well, not only your vertical industry's end customer. Yeah. So that was a short introduction, and it was a bit longer than we would normally do it, but because this is the first time that we introduced the idea of partner-ready software at all, a short introduction of how we got to do what we're doing right now. And now we get to the session focus, which is production this time. There will be other events where we'll be focusing more on training aspects, on marketing aspects. For now, the session focus is production. We will give you a brief overview over the general scope of what production is all about. Then Mark will go deeply into architectural principles and design patterns. Then we will talk, and that is the bulk of today's event, about coding ideas that we just discussed. There will be a little bit about tooling, and then we'll be happy to get into a discussion with you. So the general scope, if you look at production, is a methodology of development. For instance, Scrum, something that Microsoft actually does now, something that some partners do. The way to come to a professional software architecture instead of just piling up industry functionality. There is best coding practices. There is object-oriented coding practices. Now, we all know that NAV is not an object-oriented language, but it is indeed possible to look at it that way and to kind of get to a more object-oriented approach in coding. There's lots of tools for the industrial generation of ISV products, and that you can even make use of in a project. So Object Designer is not at all that you've got. A few of the tools are on display in the expo here. Then how do we come to a cloud or app-like product philosophy? And the last point is on security, stability, documentation, and training. That is the scope of what we think we should look into when we talk about production. As I said, we're going to focus on architecture and best coding practices today. So, and why are we doing it? As I said earlier on, current ISV products have been started as projects. They have been developed foremost with the aim to add in-depth functionality to NAV. They are excellent collections of vertical business features, but they are not software products. And that is the problem right now if you go forward to cloud, apps, and so on. They are not designed by software architects to be self-standing products. I know this is all very general, but there is truth, I think, in every product that we have. They're not designed for optimum compatibility with NAV. The functionality is often not coherent and consistent. There is no clearly defined in and output, no API-like function, and there's no easy or at least clear extensibility paths for partners. Now, that is a very general statement, and I know that some of the partner solutions out there have made great progress in that direction, but in general, these are the problems that we see in the channel right now. So, Mark, help us overcome them.
Okay, so we're going to talk a little bit about the architecture in the NAV product, the architectural possibilities. When I design new functionality, what type of data model I'm going to use, how I'm going to store the data in the database, how am I going to move the data, how do my transactions look like. And one of the great quotes that Michael Nielsen said a couple of years ago at Directions, when we were moving from the classic environment to the role-tailored environment, was don't do it the way we do, but do it the way we say. This doesn't necessarily mean that everything in NAV is bad or everything in NAV is good. There's really good parts to NAV. There's parts in NAV that could be better, and we're going to try to discuss, and we tried to break down all of the different ways to make a data model like you see in the standard product, or sometimes not. Okay, so
we get to the architecture
yes.
point, yeah.
It should have been switched.
Should be reversed. Okay.
Yeah. So we're going to talk about data models, design patterns. We have some good and bad examples. If you look at the standard product, and of course, these are opinions. They are not facts. And we're going to talk a little bit about how to make a decision if you need to start build something new. So data models. We have 2 slides with 6 models. We looked at the standard app, the Cronus app that Microsoft delivered, but we also looked at everything that we have developed the last 5 or 10 or 15 years, and we tried to come up with a list of ways to store data in Dynamics NAV. This is not a complete list. We would love to have feedback. If you have a 7th, 8th, or 9, or you say, well, this is not 2, this is 1. We would like to have feedback on that. So if you look at the first column, I think it's by far the most common way to do a data model. But it's also, if someone is new to the product, it's one of the models that is most difficult to explain to someone who is not familiar with NAV. And that is called, we call it journal posting. We had different names, but basically what we mean with journal posting is you have master data, like an item or a resource, then you have a journal, and in a journal you can say, well, this resource has done that, and then you post it, and it gets into the ledger entries. And we think the journals are the foundation of the NAV product. If you look at the history of the NAV product, they have been there forever, and everything else is kind of like stacked upon the journal posting. And one of the great things about journal posting, it uses SIFT for 100%, because without SIFT, it would be next to impossible to be able to even think about using journal posting. There are downsides to journal posting as well. And I think we are all familiar with it. One of the biggest downsides of journal posting is the bad concurrency. And that is something we inherited from the classic stack. That if we post something to a journal, we create a register, we create entries, and we want these entry numbers to be exactly incremented by 1. And if a transaction fails, we don't want these gaps in the numbering. It doesn't say that it needs to be that way. We have SQL Server now. We have other technologies. We have auto-increment. So you can redesign it. But if you look at the standard NAV product, journal posting it doesn't come with good concurrency.
And I always thought, Mark, that journal posting was the only way to do stuff in NAV. That's not really true?
And that is one of the things that we would like to discuss, is that a lot of if you look at the solutions that are out there, once you get the hang of journal posting, you kind of think that this is the only way to do it in NAV. And there's much more ways to do data modeling in NAV than just journal posting. And if you look at the base product, especially with the introduction of the latest job functionality, the nesting of the journals, which start to post each other, is starting to get ugly. Because if you have an item journal posts GL. If you have a resource journal posts GL, and job is like the highest level. I think I have a schema in my book that the job is the highest level, and from a job you can post a resource, you can post an item, you can post something to the GL, but something ugly came in that in Code Unit 12 it says, if this comes from a job journal, then don't do it. And if you see code like that, then some switch should be turned on, say, well, this is bad design. This should not be necessary. The second most popular way to store data in NAV is a document. And the good thing about the document, and that's also what Michael Nielsen said yesterday when they started the PC Plus application, is that using documents is easy for end users to understand, because basically they have on the screen exactly the same as they have on paper in front of them. If you have a purchase invoice, there's a header on the purchase invoice, you have lines, there's the VAT, and it's exactly the same as it is on paper. It's very quickly created with a minimum number of data. If you look in NAV, if you look at the sales header and sales lines, there's bunch of fields. But when it comes down to creating a new one, you only need to populate like 3 or 4 fields, and the rest is done automatically, unless, of course, you want to integrate with other parts of the application. And the business posting is done via status and posting. So if the document goes in the organization and it starts moving around, it's first it goes to a status process, an approval process, and then when the document starts to physically change, so a sales order is no longer a sales order, but it's shipped. As soon as it's shipped, it's physically a different document, so it gets moved to another table. Documents have extremely good concurrency. If you look at a multi-user environment, if you have 200 people keying in sales orders, number series can be a drag, but generally you can have hundreds and hundreds of users creating documents at the same time. Except if you start posting, then you get serialized. But fortunately in NAV 7 we will have background posting, so it will be stuck in the back. There is one downside if you look at the standard product. If you look at documents, and there has been a lot of discussions about normalizing in Dynamics NAV. And documents in Dynamics NAV have a tendency to be over and under normalized. If you look at all the fields which are in the documents, if I fill in a customer number, everything gets inherited. And if I then change the address of a customer, it doesn't get updated on the document. And for some end users, this is confusing because they think, well, if I open this document, you're going to grab data all over the place. But we are just basically actually looking at one table, and all the fields are just in that table. On the other hand, if you look at all the documents types, it is over-normalized, because I have a quote, a blanket order, an invoice, etc., all in one table. And the general idea is that, well, hey, all of the business logic is the same. But if you argue with that, you know, the business logic is all in the table, and maybe the business logic shouldn't be in the table. If you put the business logic nicely into libraries, then you can have 5 tables and still reuse the code over and over again.
There are fields in return orders that you don't need in quotes, right?
Exactly. And the other thing about documents is that they are really easy to archive. You can make a copy of the table and then store copies of it. And basically, journal posting and documents are the most popular ones. And when people design new software, they tend to start with those. But in our opinion, a document is only a document if it's can be stored on paper. If it's not on paper, then maybe you need another way to store your data. And one of the possibilities is the process model. And the process model, if you look at the standard app, it's the way that things like manufacturing is done and job is done, is that you start with this process, and then step by step, by different people in the organization, things get together, and each time that you shift a status, process routines get started, and then a process routine can create a document, or a process routine can create a journal, and then in the end, everything gets together. If you look at a process generally doesn't do posting. There is no posted job, there is no posted manufacturing order. Then there is something which you can call archiving. And this is something which is confusing. It's confused me when I started NAV. So what is this thing with posting? What is this thing with archiving? What is registration? And the way I look at it is, if you do posting, the document really physically changes. And a sales order gets multiple shipments, and it gets multiple invoices, and there's a many-to-many, and there's really something going on, and there's a different piece of paper. If you look at manufacturing, if you go from the every next status, it doesn't really change the manufacturing order. And but there might be a point where you want to say, okay, I don't need all of this data in my table anymore. And this is kind of a missing level in the standard product where archiving comes in. And basically archiving says, I'm going to take a copy of the data, store it somewhere else. If you're interested, you can open it. But if I'm filtering on the active data set, I don't have to go to all of those old data. There is something in NAV where you can just archive a sales order or a purchase order, but archiving is generally something that is missing. The downside of archiving is that it's getting more complex for end users. Well, if I have a customer on the phone and they start asking about something that happened last year, is it already archived or not? So for end users, it might add complexity. If everything is in the same place, it's much easier. It's the job that we did 10 years ago. It's still in the job table. Then there is something which is event-driven. And event-driven is something that you see in the Dynamics CRM application. So the Navision CRM, not Dynamics CRM. Oof. But if you look at the way that is designed, there's a lot of these one-time events in the database. I create a to-do, I create opportunity, interaction log entry. And we had an argument with the three of us even, say, okay, if it's an entry, it should be posted to a journal. And, well, no, if it's simple, then maybe an entry can be created by a wizard. And if you call it an entry, I mean, should it be a to-do entry always start to go through a processing code unit, or just remove the entry and then all of a sudden it is okay? So I think events and creating small entries is a very powerful way to store data, and then later on you can start the process. The last model that we have defined is a very interesting one, which is called, which I call indirect data.
So, and what is that all about? Sounds very interesting, but
yeah, well, it's not a really long list.
Is table data. I don't get it. Mark.
So if you look at NAV, basically the power of NAV is that if you build a page, if you build something on screen, you always, or the tendency is to always match the data which is in the table. In NAV, a page is a table. Basically, you could even, and I heard it in the DOS product, there was no form. You just run a table. But in some cases, the user may not want to see the data like the way it is stored in a database. And sometimes for your process, for creating code, it might be more efficient to store it in a different data model than you want to see it on screen. And a typical example is if you have a manufacturing process and you want the user to key in what happens on Monday, Tuesday, Friday, Saturday. The end user wants 7 columns and be able to easily see what is happening. But if you start making AL code, you don't want to say, if this field Monday is populated, if this field Tuesday, and then run the same code over and over again. You just want a field code and a field type saying, okay, this is Monday. And this is where the possibility comes in to have a page with a wrapper table, which represents the way that the user can see the data. But when the user enters the data or views the data, you start your own transaction that communicates with the database. And there are a lot of opinions about it. And NAV, there are a few examples, like in item costing or item tracking, where it's done. And personally, I think it's a great way to store data in a way that your process can be more efficient. So then we have this great data model, and users can start doing their processes, but the data in the process should be moved around in the database. So apart from your table structure, you also have your design paradigms. And the columns, we have also here six columns. Columns kind of...
columns, Mike.
Sorry?
We have no 6 columns.
Yeah,
We
6.
only have
Definitely
6
not.
columns. Yeah, okay.
So we have 6 columns, and they kind of represent the way that we store data, but not completely, because not everything gets posted. So if you look at journal posting, basically that's all chewed out to the very bottom. If a very good example in the standard app that is not being more complex over the years is resources. Basically, resources is the best representation of how the pure journal posting should look like, with just a master data, just a journal, a register, and an entry. And on top of that, you can make it more complex. If you look at the GL, you have, when you post a GL, you can have the customer number, the entry, the vendor entry, the detailed entries. How many people know that the entry number of the customer ledger entry is exactly the same number as the turnover in the GL? Okay. It's like...
Old news.
No, it doesn't wash all hands. So. But in the end, you still end up with the bad concurrency. Document posting basically means transferring it into another document. Posting isn't archiving. Archiving is just transfer field, insert, delete. That's archiving. Posting is that, well, okay, moving data around. If you post a sales shipment and it's a partial shipment, you need to calculate the remaining amount. So posting is really where your business logic comes in. And usually with document posting, there's a one-to-many relationship with the results. And a document posting creates a copy of a document or a new document, but it will also go into the journals. And it uses the journal as a wrapper to create one or more entries. Then there is data processing. And data processing is basically when in the manufacturing order the status changes. Nothing really happens to the manufacturing order. It doesn't change quantities of being produced, but it does create all of the item ledger entries, and it starts doing things with journal. It also can change master data. If you look at inventory valuation, it turns on some flags. If it's done or not, and it can create entries directly if there is no traceability required. If you look at segments, if you register a segment, it can create entries, and there is no journal. So, and one of the things is that if it's not necessary, don't make it too complex. Another way to move data around is data validation. Basically, something happens on a field, populating other fields. It's not really posting, it's not moving much data around, but it's just when a field changes, something happens. There are many good and bad examples in the NAV product. And archiving, like I said, is a really simple transaction. It's just a one-to-one copy of the original data. It doesn't create new documents, it doesn't create journals. And the last one we put in here is interfacing. Interfacing is something which is not many things in the standard product interface. There was this BizTalk thing, I'm not sure if it's even still in or not, but if you look at how to design an interface, there's a best practice way to design an interface. If you have a flat file or EDI file or XML file coming into your system, generally the way an interface is designed is by first making a wrapper which exactly represents your interface. So you get a file, then you get a table, and the data in the file is exactly in your table. And then from that point onwards, you are starting to use that wrapper to go into the points in the database. And if you want to have traceability, this wrapper table can even be a historical table, so that if someone says, how does this sales order get to be like this? Then you can say, well, this is the way the customer sent your file. You don't have to go to the file system. It's much more traceable.
So to kind of give this maybe a bit of a box to put this in, is we have learned that there are more than one architectural principle in NAV already. And maybe you can even come up with more than there are in NAV. Or what you should do if you develop your own functionality, your own architecture in a subsystem, is look at what architectural principle would best suit your business case. It's not, don't just do it on your own, and don't just do journal posting because everybody does so, but look at what your business process is really like. And we've tried to give these architectural principles names so that you can refer to them and say, this process looks a bit like this document thing, or this archiving thing, or this process thing. And then you can more easily build your architecture in analogy to what is already there, and it's more easy, I hope, for everybody to know what he's doing and what kind of principle he's following and what that means for the design of his software.
Okay, so if you look at the standard product, we have created the list, and the list can be longer or shorter, and you can agree or disagree with things which are, in our opinion, good design and bad design. Basically, our opinion is that the basic journal posting architecture is a really solid way of moving data around in the database and be able to trace what has happened. The documents, like the sales documents, really are a perfect way of giving the end user the idea that what he is doing really matches with the system. Of course, we don't agree with the way that the document types are designed. SIFT, I mean, who doesn't love it? SIFT is great, and SIFT should be used wherever it's possible. Manufacturing is a really strong built solution. Pricing and discount calculation, the way that in Code Unit 7000 and 710, the prices and discounts get filtered, and there's a really easy way of calculating the highest price, the lowest price, the latest price, and it's really easy to change that.
And you may have business processes that have got nothing to do with pricing, but follow the same architectural principle, and you should maybe look at that code and do it the same way.
And there's detailed and value entries, which basically allow you to update existing entries without changing the data which is in there. So if you have a posting process and you think, well, I need to update an entry, then a flag should go, I don't want to update. If an entry gets created and there's points in time where extra information come in, think about having value entries or detail entries, because the power of that is traceability and locking. I mean, you don't want to start updating old entries.
And transferring incrementally to data warehouses and not having to
go
like back.
Yeah. Like we said, the bad design, we all agree that the document types in sales and purchase really doesn't really make life much easier. When you start doing it with a new document, it might make sense, but you never know where your software is going to end up in 5 or 6 or in NAV's case, like 24 years later. VAT and currency calculation. I think VAT is an excellent example of a missing class library in NAV products. There are so many places where the VAT is calculated and it's being done over and over again, and if you change something here, then I forgot to do it in 81, and I forgot to do it in jobs, and everywhere the VAT gets calculated over and over again. And this is definitely...
Which actually also have positive points, because when I have to have a VAT calculation, I can copy it from wherever.
Oh, it's much easier.
I can find it very easily. So.
Dimensions is going to move from bad to good in 7. It's on the list of plans to redesign. But if you look at the way dimensions are stored, there's so much redundant data at the moment. If you look at a 120 gig database with a lot of dimensions, I think easily a third of that database is dimensions. We love the way that you can work with dimensions and analyze dimensions and what you can do with it.
In my opinion, in fact, this is a very good example how to make something generic, because when you have your own master data, putting the dimensions on that is quite easy. So the design from that is quite good,
It's
but
good,
the data
but
model behind it is somewhat questionable.
Exactly.
Yeah.
Job posting, I mean, I love the new functionality in 5, where you can do much more with jobs, fixed price jobs, doing 40-50% invoicing. But if you look at the posting model of jobs, it hasn't really been improved. Entry number concurrency, we already talked about that, and there's not really much good examples in the standard product about interfacing. There is no BizTalk buffer table which stores all the BizTalk requests before it gets doing something with sales documents. It all of a sudden something in the sales document appears, and if you are say, well, where did it come from? Someone needs to grab all the old business data, and it's not in NAV. So decision making, if you are starting to make your own application, or you need to expand the application, look at your business case, what do you want, and decide to choose the right design pattern. Consider performance. You know that if you use journal posting, you end up with locking. So consider performance in every line of code you write. Security access control is really important. If you put everything in one big code unit, how on earth are you going to set up security? So if you want something to not be able to do something without having all these Boolean flags in table in the user setup, like everyone has, right? You have all these setups, and setting up a new user gets like to be a nightmare. So the more code units you have, the easier it will be to have access control. Integration, try to make your solution as app-like as possible and interface with the standard product. We're going to talk about that later when we discuss code. And try to make a decision about enhancing existing architecture versus create your own code. Do I really need to go through code unit 80 to create a sales invoice? Or can I just do an insert on the sales invoice table and create the customer ledger entries and just skip code unit 80? It might make my solution much easier to upgrade. All consider, you can even make your own sales invoice table. I mean, it's just a table, right? There's no God saying this is the only sales invoice table that is allowed in NAV.
Yeah, and
so
God is 24 years old now, so
yes. So to summarize, there's more in life than journals and documents. Posting and registering and archiving is different things. And if someone says, this is how Microsoft does it, it's not always a good argument. They made mistakes themselves, and not everything in the base product is good. And not everything in NAV is to be copied, but the foundation, we don't want to argue about the base foundation. We love the base foundation.
Which means that now we get to the juicy parts, and that's why Eric is here. We get down to actual...
Do you mean I'm juicy or something?
No, you're an expert. We get down to actual coding examples, which we hope some of you will have employed and some of you will have never seen. I hope that there's a mixture of both, so that you get some of what we call fresh ideas, and maybe can see that some people have come upon the same ideas that you have come upon 3 or 4 years ago, and consider them valid as well. There's a whole list of different coding examples that we will be showcasing and showing you through. You see that list here: atomic coding, making .NET interop available, object-oriented way, and so on and so on. We'll get to each part of that in a minute, and they're all just examples of how we think that modern coding architecture could look like, or should look like.
And these are examples. This is not copied from a business case, but just a little bit exaggerated to show you a point and make you consider stuff, of course.
Exactly. So what is atomic coding, Waldo?
Well, what we mean with atomic, it's like an atom. I guess everyone knows an atom. We've got one in Brussels. But that really doesn't make our point because that's quite big. And with an atom, we mean something quite small. It's actually the smallest particle ever. Can I have that?
Yeah, physics are a bit old-fashioned, but anyway.
So what we mean with atomic coding is break things up as small as possible and make things as reusable as possible. What we mean with things is, of course, functionality. So, and also name them and like you write a function, choose a decent name that describes the entire function. You just try this to show you with this an example. I was actually kind of bothered with would the screens be big enough, but I think there's no problem here.
They can see it in Brussels.
Yeah, in Atomium. What we see here is actually kind of readable, I guess, but we are all nerds, we are all developers, we can all read this like there's no problem, and it describes at the top, create new sales order. Okay, this is an example. Creating a new sales order is also business logic. What do we have to do to create a new sales order? And if I would like to find out by reading the code, I have to be a developer to read it, for sure. And yeah, what is it actually doing? It initializes something, then it's going to insert the header, then modify the headers, but that is not really readable at this moment. And what we mean with atomic coding is this is actually kind of like the same. Turn the other way. And here, oh my God, that's the wrong button. Here at top is actually the business case, the flow. My mic is disappearing. This is actually calling out to chunks of code which explains better what is the business model.
Let me help you a little bit.
Oh, you touch me. I've got another side as well. So initialize sales order. This exactly describes what I want to do. And it's only maybe one line of code, but it's readable. And that is what we mean with atomic coding. We'll touch this by viewing it from another angle as well. But, okay, atomic coding is...
And you see what that first function does. It actually gives you a flow chart of what you need to do to create a sales order. It is structuring your thoughts. It's exactly how you thought. The other code was exactly how you thought as well. Because you're a developer, you can just code it like that, and because it's an easy code. But these are all the single instances that you have to run through. And here you have a physical, a readable representation of what was actually in your head when you wrote that kind of complicated, nerdy stuff that we've seen earlier on.
And if you think in an atomic coding kind of way, you actually first have to think of, okay, how do I have to do this? And write it out in sentences like the first function. And that is going to be your flow chart. And you can do that actually right away, not maybe all the code behind it, but then at least you know before you start coding what you're going to have to do. And coding this way is much easier than the first thing, because when you go back...
I mean, that's a very easy example for developers.
Yeah, sometimes you get something like Code Unit 80, and if Code Unit 80 was written like this, I think we wouldn't have bothered or mind. We would have bothered. We wouldn't have minded that.
But cannot compile. Did you ever compile as well?
Excuse me?
Cannot compile. Your code cannot compile.
Because?
It's because of the parameters in the function.
But this is example code.
It's
a statement.
Yeah.
Okay, the other code examples you're going to see won't compile either. So that's the first thing. You need to structure your thoughts first, and that's actually what we want to force. First, write out in sentences what you want to do as business logic. And these are actually your functions. And also use proper names, so that's always nice. Next thing, making .NET Interop available. We've seen vehicles session. Vehicle has seen vehicle session. .NET Interop, I don't want to compare it with automation, but the point we want to make here is actually kind of like the same. When you're using .NET Interop and you're using automation in the classic, you don't want to use that DLL or .NET in all code units where you need some small function of that DLL. And what we try to encourage, and I took actually my own example. It's quite small. I will take that one. This is actually the Walden NAVPath. I don't know if you know the NAVPath, but it's actually just a DLL that is able to get a big chunk of text and going to break that down in a somewhat intelligent way. Let's not call it intelligent way, but in a way that is still readable. My first solution, I've put that download or that DLL or the usage of that DLL in the business logic. So what does the DLL do? It's actually described here. It's appending texts, so you can add text to the DLL, and then after that I can break it down in chunks of other text. I can show a dialogue and things like that. Actually, the call out to that DLL, and maybe I want to use that on the comments of a customer. I want to use it in the comments of a vendor. So I can use that in different kinds of business cases, business logic. But I don't want to put my DLL in that business logic because when the business logic changes, I cannot compile if I don't have that DLL on my machine. And probably we all suffered already from that problem. So what I did in my last example, I just create a code unit that has every function of the DLL. So I've got a show dialog function, and it just wraps it to the DLL's function. I've got the get count, I count it. So that's what I mean. I actually just create a wrapper code unit for that. I know this code unit is never going to change because the DLL is never going to change. And as long as that we've got that in the FOB file, as long as we don't have to change it anymore. And if my business logic changes, so if I want to have this functionality now on a new comment table, my code unit is there. I don't have to even have that DLL on my development machine. It is just already there. So what we actually want to say here is just keep the declaration of the DLL as far away from your business logic as possible. This is the next lines of code. The next thing is object-oriented way. I'm at my company. I'm a development manager, and I sometimes have to hire new developers. And if we are searching for new developers at schools, for instance, the first question I get is Navision? They still call it Navision. I still call it Navision as well. Is it object-oriented? And that's always a difficult thing. Why is that so important for the beginning? And in a way, I think, and also we talked about that, NAV is not object-oriented, but you can think of it as in an object-oriented way. And I give here 2 examples. This one is a code unit. And what I did here is actually I created some constructors. So what the code unit basically does is it's my bank account functionality. It can be anything. And my bank account in NAV can have some properties, of course. like get the bank account number. The bank account number is kind of an important property of the bank account. And it has some functions like import the bank statement and things like that. So you get methods, properties, and constructors because you have to construct. And as long as you have that quotient in memory, you get that bank account in memory. This is very small, stupid. We actually it's just an example. We don't use it in production, and it probably won't compile either. Actually, it does, but yeah, it is a way of doing it in an object-oriented way, and you think of it completely different, like this. Another thing, another way of thinking object-oriented is using a table as your object. And when your table is an object, or a class, actually a class, then your fields can be the properties, the attributes. Your functions on the table can be your methods. And in that way, your table is actually the instance of your object. And if you create a record table or record variable, that can be the instance of the object. Create a record of a customer, that is actually the instance. And if I can do anything with that. And if you look at, it's a little bit abstract. He had to convince me yesterday to do it that way. But actually it makes sense. What I would not like to do is put the actual business logic in that table. So you can create functions, but the functions should call out to code units or whatever to actually execute the business logic. I think we've got an example as well. So this is a table which has some methods, and as you can see here, the methods are calling out to the code units where the actual business logic, in my opinion, should be. Because you can see the tables.
Well, what you have here, normally you get all the fields of a table in IntelliSense. You press F5 and you have a list of all the fields, but sometimes in NAV the functions, the actual methods are hidden in some code units. You have to know that you can call these code units and the functions are there. So it is nice to make the table sort of a collection of its methods as well. Or the code does not reside in the table. So you have all of these functions on the table. You have everything, every field of the table in your IntelliSense F5, and you have all of the methods that it can handle there as well, like posting, for instance. Code unit 80 is not realized in IntelliSense. Of course, you know that you can post a sales header, but you don't get that when you press F5, like you would get in a normal Visual Studio .NET environment. But maybe you can rewrite that and have that function sales post that calls 81 and then 80, when you do that, you have that function on your table actually, and it is within IntelliSense, and we're opting to make that more in a more structural way, so that you know everything that I can do with that table, be it a field that I can populate or be it a method, a function that I can refer to, is always there when I press F5, like you have in any normal programming language. UI separation. That's another thing.
It's a classic one, right?
That's a classic one. Of course, all this three-tier architecture is about separating the UI from the business logic and the business processes.
This is also because you cannot program on pages, right?
Yeah.
Or have they dropped that? I don't know.
I don't know. let's see that. But you never know where actually your business logic is being called from. There is Windows Phone 7 now. There is web clients. There is SharePoint clients, and we've seen a lot of third-party vendors who have web client possibilities here in the expo. There is everything. You don't know where your logic is called from. So we think that it really makes sense that in your code you strictly separate anything that does UI from anything that actually executes business logic. All business logic should be UI independent. There was a question in the testing session now from Bas that says, what do I do if my business logic contains 3 different dialogues at separate stages of that business logic? How do I write a test code unit for it? It is possible, but we would rather say restructure your code. You shouldn't actually in one business functionality call 3 different UI elements that you need to react to. I would even go so far, and we would even go so far to put UI-focused logic completely in different code units.
So I cannot say log table find last and then if confirm.
Exactly.
Okay.
And it should also be possible to turn that UI code off with a single switch. If you could switch.
I can switch.
Single switch only. Yeah. We see that kind of here as a very, very basic example, which I hope compiles. You have something that you need to do, update the sales price, and typically what you have before is a confirm that you actually want to do that, and afterwards show that acknowledgement that the sales price is updated. And what you see is that we have a code unit saying sales price update UI, and we have a code unit saying sales price update. So you have that message, update sales price, let's say on the sales line table as one of your methods. And what it does, it separates the UI from the actual business process. It first calls out to the confirm UI, then it executes the business process, and then it calls out to the acknowledgement, which is in the UI code unit as well. And actually in your business logic, in your testing processes, I would only test the middle thing here. The UI is not kind of very testable anyway, so you don't need to test that UI here. And there is a high dialog boolean with which you can turn off all UI if you want to. Okay.
I'm not actually. I don't dare to turn slides now because I know that a lot of people won't agree with me, but I'm still going to.
Go ahead. Come on.
Everyone likes comment, right? But actually, I'm probably, or we are probably kind of the only ones who doesn't, because in our opinion, having to comment is actually just a way to get out of the bad structured code. And if you don't know what you're writing, then usually you're commenting, okay, now I know, and you can continue. But actually, as I said, I'm going to view at the atomic coding and some other viewpoints. This is another viewpoint.
So if you have to request for another color, not green, but red.
Yeah, it shouldn't be green. Now, this is a theory. Sometimes, of course, it is as difficult as it is, and the restructuring is just not possible. And then, yeah, of course, commenting can help as well. But in general, we would say that, if you have to comment your code like this, which looks like kind of nice structured, but then all the comments, in my opinion, or in our opinion, it's just a function. So you could, and probably it won't compile as either. But anyway, you can also do it like this. It's also a nice viewpoint, I think, on the atomic coding level. And it's again, you have your base thing that describes the flow, and you don't need comment actually. Anyway, if you read it, loop through sales, or there you go, loop through sales, okay, throw error if no assignment purchase line, and things like that. So it actually explains the business logic by just reading the code. And reading the code, in this case, it's just reading the functions. And this is also an example of, a little bit. Right? This is actually, what was your company? So, like I stated, in general, comments, in our opinion, are, a way to get out of the badly structured code. But on the other hand, if the developer himself feels like he has to, and he doesn't understand the code that he's writing today, that he won't understand it tomorrow, and he has revised his structure, and he says, okay, I can really not do anything better, but it's quite complicated, okay, put in some comments.
In many instances, we find that the obvious is commented, like get purchase header now, and the line is purchase header get. And the really, the stuff that's really difficult and that you really have a hard time putting into code, you don't comment because you're not quite sure. It takes time to actually say why you've done what you've done. But the obvious is always commented first, and then it doesn't add to the general information. It just subtracts.
And also when you're working on a certain functionality, which takes quite some days, and you're struggling with it because things are just not working, which happens, of course, not that much in NAV. Then, of course, after a few days, you finally get it to work. But then usually you realize, oh, my structure is not that good, and I've got the answer now, but okay, I can do it this way. I didn't know that before I started, so I should restructure. Well, let's just put in some comments and everything is fixed.
Yeah, this is another way of realizing certain requirements that we called iHook. A former colleague of mine called Miguel Flaminio has said that the correct term would be facade technology. I used to refer to it as three-tier coding, but with three-tier NAV coming around, that's not so good anymore. What is it about? We'll show you a diagram just any minute now. What it does is it should allow flexible interfacing with third-party tools or big functional blocks inside NAV. And it is a way to implement something like overloading or just-in-time compiling in NAV. And that is not okay for all purposes inside NAV, but is highly suitable for anything, as I said, third-party, for attaching processes like calling out to Weybridges, to scanners, to scaling systems, telematics, to archiving systems. And what it does is it is done by a complete separation of business logic from its functional representation. And in the middle you have a facade. Let's maybe look at the diagram to make that more clear. Just think that you have a page or maybe even a code unit that calls out to a Weybridge to get some weight. Normally it does so, or in an old-fashioned way, by directly interfacing to something. That could be a DLL, or that could be something else. To make this more flexible, what you could do is put a facade code unit in the middle, and all this facade code unit is very, very stupid. All it can do is find the right interface for you. That is the idea of it. So the business logic says get weight. The facade code unit also has that that function that gets the weight, but it doesn't actually do anything. It only knows where to call out to actually get that weight, and that allows you to implement different interfaces at the same time, because your customer will have different Weybridges. If a customer has 3 Weybridges, he has 4 different systems. That is a very well-known fact. So this is a way of calling the same business logic in different interfaces. The next slide makes that a bit clearer. I hope you have a page that has a function that says get net weight. It goes to a facade, and the facade actually knows which interface implements that business logic. In that way, you can have people describing or implementing processes on the left side that they know will always compile, because they will always just go to the facade code unit. And you can have people working on the interface side that do not actually know how the business logic is arranged or where it will be called. It is they just know how to get the interface working. We have actually employed that a lot with what I've said, Weybridges, scanning systems, and it makes code very easily interchangeable. Of course, you know the interface side, you know the page, the business logic side. A facade looks, or in our case, always looks somewhat like that. That is the only about the only thing that is in the code unit. It is called to implement the interface. What it does, it checks If a method exists that is to be implemented, then it finds the interface and then it runs the interface. That's all the facade does, finding the interface and then calling out to run it. And it finds that interface by different methods, normally by the method itself, because the interface is connected to the method. It can also find a default interface if there is no interface directly connected to the method, or if there is still no interface found, it finds the interface maybe by a hook in that you have programmed yourself. And if it doesn't have an interface after all these attempts, it will throw an error that there is no interface for this method. What this allows you to do is it establishes a contract between a business functionality and the interface that implements this business functionality. It allows developers of UI and developers of interfaces to act independently. And it allows modification, extension, or even complete exchange of interface without having to touch the UI or the business process at all. You can implement many interfaces that can coexist, and maybe one interface is used by that weighbridge, the other is used by another weighbridge, or you have a new functionality that the administrator needs to check out, and that functionality only goes to that special interface which is evoked by a relation between the user and the interface he's likely to get. So you can have business logic in many variations in the system at the same time, and you don't need to switch around code. You just throw the interface in, and you make the facade through setup point to the relevant interface. That's a very good way of being completely independent and not having to touch your generic code every time. Encapsulation, just shortly, because we were already really down in time. Be as local as possible. NAV isn't always local as possible. On forms and pages, you have many things that are just global, which shouldn't be. Ideally, be as self-contained as possible. Ideally, a code unit, and that represents a method. Contains only one public function, the rest should be local. This is exaggerated, it depends on the type of code unit. Of course, you have code units that just give you a lot of helping functions, but ideally always look to that. You have an entry point into a code unit, and that has some lots of little helper functions to actually execute that, and they should all be local. Doing so, you create more secure and more modular and above all, more structured architecture. You don't allow access to everything you've coded from everywhere. That also, by the way, makes testing a lot more easy. Eric, anything else?
Yeah. I get a new view on that atomic stuff. You'll probably... At my company, also business people and implementers are reading code to sort out what is going wrong maybe or what is happening. So getting that code readable to that business or that implementer is, no, the consultant, actually that's the right word, the consultant. Is also quite important. So you have to make a distinction between the business process code, which is actually the broken down methods that we call in the atomic coding, and your nerdy stuff. And this is actually quite a good example. Yeah. The get item is item.get, and it's really it doesn't really make sense. But on the other hand, item.get is nerdy, and it's not that readable. Then get my item. So that is just an example. I'm not saying that you have to replace all your item.get with get item, but
if you have more complex examples, it would take like more hours to show.
Indeed. And this, the screen would have been big enough to actually show more complex examples. But anyway, so you have to differentiate between the code for the implementer, maybe if I can't call it like that, the business process code, and the code for us, the nerdies. And again, to point out the flow chart, all the business process code is actually the flow that the business logic is following for executing the business logic. Now, does someone knows Mark's blog?
I don't think they know my blog.
Actually, you're lucky.
Three hands.
I asked that once in the session. Does anyone know my blog? And nobody knows it. I never do that again. That's quite embarrassing. But anyway, Mark wrote something about Hungarian notation being not really useful. It's actually an old standard, and if anyone can give me a good reason to do it, besides the fact, then I can read code that I have written, and it is distinguished from the code that Microsoft has written, because there are other things for that. And I think we showed that today. So, and I actually do love Michael Jackson, but anyway, I've written the last sentence. I do not do it like that, actually, when I just write in English. It's not PPNI, the verb love, Michael, and Jackson.
So that's I love Michael Jackson in Hungarian notation, personal pronoun I verb love.
So that's not readable either, and using Hungarian notations is not. If you know item.get, you'll know it's a record. You know the rec item, and you don't have to repeat that all the time.
And if your structure is good, you know whether it's local or a parameter or global anyway. There's not too much information that you get, and if you need it, it's only just one mouse click away anyway.
But still, if there is anyone that gives us a good reason to do it, maybe we can change our
You can win a T-shirt.
That's true. Mark, you've got a slide.
I've got a slide. I was always falling asleep.
Thank you.
So testing, there's I think Bas gave a really good presentation about the testing possibilities that NAV has. This is information from 2010, but there's 226 standard application test cases that you can download, and you can include them in your vertical test cases. And I think the most important key takeaway here is that if you write a function that is not able to be tested in the testing framework, then it should not be written.
Or to say it in another way, if you just seen Bas, I think it was, Bas's session, and you say, oh, I cannot implement this, that's actually a sign that you don't have the code to implement that. So maybe you should reconsider and re-engineer the code so that you can implement the testing functionality. So,
tooling. I don't want to make too many words because the time is running out.
The time is running out, and I'm on a tight schedule on that. So let's go. Okay, tooling. How to think about it? There are a lot of tools, and we have been using something called Object Designer quite a lot.
Who has been using Object Designer?
Who is familiar with Object Designer?
Sorry for the question.
That has been one of the only tools we had, but actually there are a lot of other tools, and what we will try to do with the partner-ready software concept is to categorize them, and just not making them available, but just making you aware that there are other tools and Object Designer to do things. Now there are lots and lots and lots and lots of tools, and we didn't do our own work yet to categorize them, but it will be the case. When you can find them, of course, Mibuzo. I've put the other one as well.
The other one,
of course, dynamicusers.net, which all
is
of you know as well. And we've put our own website on it as well. So we are going to categorize it, and we can find maybe some useful things there. There is not only the Object Designer. There are a lot of tools that can make your production process a lot easier and standardized and things like that.
And I think here's some more resources for you to get back to. One is our website that is up since Monday, partnerreadysoftware.com with minuses or hyphens in between. You can follow us on Twitter if you have got nothing better to do. That is PRSNAV. You can also do that from our homepage and click that. You can like us on Facebook. Please don't dislike us. LinkedIn is under construction. There are several blogs. Waldo's blog, of course, everybody knows
You can
that.
read them if you don't have anything else to do.
And it'll point to new things on our website. Anyway, there's Mark's blog, and my blog is still under construction. Under construction, you have our emails here. If you have thoughts to share, criticize, or whatever, we're looking forward to that. And we'll also be getting emails on the Partner Ready Software roof. Okay, key takeaways. What are our key takeaways? Eric.
Are you asking that to me? Actually, the base, I don't know who explained it, but actually my base key takeaway is the fact that you don't only have to think about the solution, but also about the software. And we're not only creating solutions. It's not fine if it works. It's fine if it's good and it works. That's actually my key takeaway.
Yeah, for me it's important that I'm pretty sure that all of our software is always next to perfect and nicely structured. But I also know that a lot of people have difficulties getting budget to redo code. I mean, we know Microsoft has difficulties getting budget. They finally get to do the dimensions, and I'm sure that everyone has the same. And I really hope that if you get into this discussion about let's redo stuff, and they say, well, what are we getting back for it? Then you can say, well, there is this story about Partner Ready Software, and you can go to the website and read it. So we can do it together and make the NAV ecosystem work more efficient together.
I restructure my code or re-engineer my code 5 times before I publish it the first time. Maybe that's just because so bad, you see, that it doesn't compile. But on the other hand, I think don't be afraid to do that. If you're so good to get it right the first time, you're a genius. Consistency on all levels, that's what we started with actually. It's not just marketing, it's not just product, it's not just consulting. Everything has to come together in a consistent and coherent way if you really want to be successful these days. It's not the marketing guys telling the techies, that's the product, now do your techie stuff, whatever that is. It's not the programmers writing the product and telling the marketing guys, now that's the product, go and sell it, whatever it is. It's bringing these people together and working together in a coherent and structured way. And these are our key takeaways. The 3 dots are for what have your key takeaways been? Questions and answers. We're a bit out of time, but the lunch break follows, and if we are ready to sacrifice our lunch. So if you have any questions, comments, answers, please shoot.
Maybe you could have taken a t-shirt.
We only have 1 shirt to give away. I mean,
No,
most
4.
of the session have 4, I think, but we only have 1.
Hello, thank you for the presentation. So my question is there a possibility to define that some solutions are built with PRC methodology?
Yeah, we want to get at that. That is a good point. We want to kind of develop guidelines of what we think should be done, against which you can check finally. So that is one endpoint.
You mean PRS approved or something like that? Or?
That is.
Okay.
That is one thing, and we want to work with Microsoft together on that to kind of so that to give you an instance where you can check against. Exactly, yeah.
Okay,
but that's a bit in the future.
Okay, thanks.
Before any more questions, I think I have to leave because
You
in
have
5
you have a
minutes
presentation.
I have another presentation.
But we are here. Here's one down there.
Yeah, I want to say thanks for standing up, so I'm standing up. Thanks for giving us this to us. One thing I wanted to suggest, one thing I wrote in my blog, could you try to connect to the all-in-one code
Okay.
Initiative? I think that would be great. I think we could push there more because it's now all C# and we're not all in C# yet. So
yeah, let's get together and talk about that some more. Good idea. Thank you.